Okay, Assalamu alaikum. This is the week 3, part 1 video for VHDL programming. So what we are going to talk about today will be component instantiations, which is how to create more and more components, copies of the same component in our program. How do we do port mapping, signals, and how to implement if statements in our programming. So first of all, let's take this example in which we want to create an entity that has K, P, and S are our inputs, and the output is our warning. So this signal is supposed to have K and P ANDed, then the output is ANDed once more with an inverted S signal. So how do we implement this? First of all, we need only two components. So we need to create two entities, one entity for the AND gate and the other entity for the inverter. Once these two are created, we will clone or create instantiations of these components within our system. So it's the easiest way to create digital circuits. Instead of writing programs, we have the circuit with us and we start creating components and connecting them together. So through this lecture, I'm going to go through all of this with you. So given the components to be used in a circuit, such as the two AND gates components and the NOT component, so we have two input AND gate components and one component. We only create one AND gate and one inverter. Now, we need to create a new entity that turns on the warning light by setting an output W equal to 1. So this warning will be W will equal to 1 when what? When K, if the car keys are in the ignition, which is K equal to 1, if key is equal to 1, and the passenger seat belt is equal to 1, and the passenger is seated, which is equal to 1, and the seat belt is unbuckled. This means it indicating with 0. So once this all is done, we will have a 1 over here. So to implement this, we need an AND gates. So basically, if I want to write a function for this will be W is equal to what? W is equal to KP, or K and P, and S complement. So to implement this using a circuit, we are going to do this implementation over here. So furthermore, one way is to define an entity as shown in the circuit. Our entity, as you can see, will have how many inputs? Our entity will have 3 inputs and 1 output. Remember, the entity is this blue box, okay? The entity is this blue box over here. So we are going to declare our entity. Then we are going to call the components that we need, assuming before that all the components are already declared. In the lab, you are going to see how to do all of this. Then we are going to see the signals. What signals we have? We have N1 and N2. Then we are going to do port mapping and run our program. So this is the program. Now, first of all, library IEEE, use IEEE.standardlogic_1164.all. This is all standard. This you have to memorize and you need to know. Next is our entity. Our entity is basically defining this box over here. This box will have 3 inputs of input standard logic, 1 output. So you have S, P, and K as our inputs, and they are all input standard logic, and we have 1 output, which is W. Then we have our end entity. So this is all done. We defined our entity. Next step is to start calling our components. We need only 2 components, which is AND 2. Of course, from the previous class, we already said that AND2 is defined. We defined AND2 entity. So in your project, when you start this new project, which is built warn, you need to add and to your project. You are going to see this all in the lab. So we call the component. So the component is and2. We call component and2 is we define its ports. As simple as that. Remember, sequence is important. So X, Y are input, F is output. End component. What other components we need? We need this inverter. Component inverter is port X and F, end component. Remember once more, I will say it for the third time. This is assuming that your components are declared and already done. You cannot call components that they are not in your project. So make sure that your components are in the project, then you can declare your components. Next, we declare the signals. What signals we need? We need N1 and we need N2. So we declare our signals. 2 dots over here, you can see them. Then what type of signals? They are standard logic. This is the part, it's like you have your test. I called my components. I need an AND, okay? I need an inverter. All of these are my components, and I need 2 wires, N1 and N2. Next step is connecting all of these in this shape. To connect them, we start with begin. This is called port mapping. So in port mapping, my first, let me clear this, okay? My first signal is this and 2_1. I give it a name, and 2_1. You can call it whatever name you want. Then 2 dots. It is of type and 2. If you want to say a type, it should be declared over here. You cannot call a type here that is not declared over here. It is of type and 2. Then port map. Port map is connecting the ports. Port map. Now, and2 has 3 ports, X, Y, and F. Tertib, sequence, X, Y, and F. Input, input, output. So port map, I come here. K is mapped for X. P is mapped for Y. N1, which is a signal over here, N1 is mapped for my F. So this is the line declared over here. Same applies for the inverter, which is mapped S, N1, S and N1, and the final one, which is N1, N2W for the second and 2. See, this one, let me clear once more. This one here will have a name. This one will have a name, 2 different names, but both of them are of type and 2. Okay, so you got the idea. You need to give different components names, but when it comes to instantiation, you connect them to the same AND gate over here. Now, furthermore, this is explaining all the things that I said. The last step is using component instantiation statement, which is very useful. A component instantiation statement creates a single instance. This is where came instantiation. Creates a single instance اللي هي حالة واحدة of a component circuit described how the instance connects to the signals. So the first part is giving it a name. Each component will have a different, each instance, كل حالة, each instance will have a different name, but all of them should be connected to the same component. Now, this is explaining, this is the instance name, this is the type. Remember, it should be declared as a component in the beginning. This is port mapping. وانتبهوا الترتيب مهم. Sequence is quite important over here, because if you do the sequence in the wrong order, then you have a problem in your system. Okay. So we have an alternative solution. إنه K and P, not S. It will do the same work. as this line وين راح okay here this line okay will do the same thing. So you have two options. Actually, we have three options. This I will discuss further in the lab. We either write a program using code, using component instantiation, or using graphical user interface where we drag and drop our components and build the circuit that we want, which is always a good option. Okay. So signals, ports, and mappings, we have already discussed in the previous explanations. We need to create our signals. Signals هم connections within the circuit inside our entity. We call them signals. We need to create all of these signals and then port map to see our outputs as, port map to connect the wires together. If you remember, I showed you just now that we have these signals and then we create them and connect them using port mapping option. Okay, this is all the same thing that I said. So I will stop here for this video. In the next part, I'm going to explain a few examples and how to use if statements within our system. Thank you for watching and hope to see you all soon.